Dear students, today we are going to solve question number 13 of miscellaneous exercise. Here the question is, find the equation of a plane passing through the points with coordinate -3, 3, 2 and perpendicular to. Nangi equation of the plane puthokadabako passing through the point the coordinates -1, 3, 2 and perpendicular to each of the plane. First equation is x plus 2y plus 3z is equal to 5 and the second equation is 3x plus 3y plus z is equal to 5. Nangi required plane sina atoba plane anida perpendicular oire point ama pharaga chatle ko tuga sigumba line nangi plane amagi equation derive tawada. Let A sina plane 1 require plane duni plane 2 and the plane 3 given planes tare ko diagram sigi matungina sigi plane se plane 2 and plane 3 the perpendicular oirani. Let A coordinate -1, 3, 2 be a point on the required plane which is perpendicular to the plane's equation of the first plane is 2x plus 3z, 2x plus 2y plus 3z is equal to 5 later. Second equation is 3x plus 3y plus z is equal to 0. Sina equation of the plane 2 tare. Let n1 and n2 vectors be the normal to the plane 1 and the plane 2 respectively. N1 formed by the coefficient of x, y, z in equation number 1 I cap 2 times of z plus 3k. N2 formed by the coefficient of x, y, z in second equation 3i cap 3z cap plus 1k cap. Sumain phange ko. Let n vector be a vector normal to the plane 1. Then from the given condition, this n vector should be perpendicular to n1 vector and n2 perpendicular direct. And so this n vector is given by n1 vector cross n2 vector. Sigi formula sinapira aniba. N1 vector cross n2 vector in terms of their component is equal to expansion of a determinant. Elements are I, j, k. Then write the components of n1, 1, 2, 3. Then write the components of n2, 3, 3, 1. Expanding this determinant, we get a vector whose components are -7 ik plus ijk minus 3k. Save khuna fast row the expand tore to sigi vector se phange ko. Then write the equation of this plane 1 passing through point A and normal to n vector. Equation of the plane 1 passing through point A with coordinate -1, 3, 2 and the perpendicular to n vector is given by 1 point form of the equation of the plane used to record r vector minus a vector dot n vector is equal to 0. Then write the components of a vector and n vector. Component is equal. Nangi r vector minus a se kuina distributive law apply to rakanda kaigi form the ibeani r vector dot n vector ko minus a vector dot n vector sigi minus a transpose of vitardi plus tare ko r vector dot n vector is equal to a vector dot n vector. Sigi formula a r vector. Then write the components of n vector. N vector की components है 7 I cap plus j cap minus 3k cap minus 7 I cap plus j cap तारे को r vector dot -7 I cap plus j cap minus 3k cap. Write the components of a की components से minus I cap plus 3c cap plus 2k cap तारे को दुका dot कनागा dot product लोगनी -7 I cap plus ij cap minus 3k cap and the scalar product of two vectors in terms of their component is equal to sum of product of corresponding component. -1 into -7 minus plus 8 into 3 24 tarekwa and 2 into -3 is equal to -6. 24 thame sigi 7 chiga -6 ka subtract taunaradi +1 25 orekwa. And hence the required equation of the plane is r vector dot minus I cap plus I times of j cap minus 3k cap is equal to 24. Sinangi required equation of the plane oitare. Next question number 18. Question number 18. Find the distance of the point with coordinate -1, -5, -10 from the point of intersection of the line. Nangi equation of the line ampere ko and the plane. Sida river point se point of intersection of the line and the plane do the kyam lap ke have distance to puthokada. Question number 18. Akoina diagram amani yeksiko. Let B be the point of intersection of this line L and the plane. Plane siga line siga ki point of intersection se B puthoe. Duga point A na represent siko. Let us represent -1, -5 and -10 be the position vector of point A sigi position ne na khalleba dude hause aina puthok tu se kaino A dagi na B bau gi distance A dagi na B bau distance means the length of the line segment AB ta doini ko let A represent the coordinate -1 -5 -10 and the B be the point of intersection of the line. Equation of the line is R vector equals to 2I cap minus A cap plus 2 times of K plus lambda 3I cap plus 4C plus 2K cap. In the equation of the line and the plane R vector dot I cap minus A cap plus K cap is equal to 5. Equation of the line is nangi equation of the line se amuk rewrite tawsiko R vector equals to 2I cap minus A cap plus 2 times of K cap plus lambda 3I cap 4C cap plus 2 times of K. Sigi second expression se lambda na multiply tawraga I common lagtho ena kalleko 2 3 times of lambda I cap minus 1 plus 4 times of lambda J cap plus 2 and the 2 times of lambda K cap. Si mayam se kanagi component. These are the components of R vector. R vector means any points on the line niko. And so the coordinates of any point on the line is of the form x coordinate, y coordinate, z coordinate tagadaba. 2 plus 2 lambda minus 1 plus 4 lambda and 2 plus 2 lambda haibadi nangi lines de leriba any coordinate ki form se sigi value chatlane ba lambda si da khoina tungan ba value silakanda position of any points phangdoini ko. Then let the coordinates of the point B be. Nangi point B se kanada lay line da sulay plane da sulay ko. And ahan bada B gi coordinates se line da gyana putho se. Let the coordinates of the point B be 2 plus 3 lambda minus 1 plus 4 lambda and 2 plus 2 lambda. Since this point B lies on the plane. Plane da so dum lay drama se haibadi masina point of intersection of the line and the plane low given ko. Since the point B 2 plus 3 lambda minus 1 plus 4 lambda 2 plus 2 lambda coordinate ni lies on the plane, equation of the plane is R vector dot I cap minus J cap plus K cap is equal to 5. Then anise khona vector form ni ko Cartesian form the on ge hai taragadi sige R vector se xyz na sin bare dun x multiply by 1 x tare ko y multiply by minus 1 minus y and the z multiply by k will be equal to z. X minus y plus z is equal to 5. So this is the equation of the plane in Cartesian form niko. Nangi plane se na nangi B have a points in a planes the labor maramna it must satisfy the plane equation. Plane equation satisfy to bom thoiko. X coordinate se coordinates of x coordinate B gi x coordinate na selasi y se y coordinate hapasi ko z se z coordinate hapasi. By substituting the coordinates of B in this equation, we get left hand side is equal to right hand side. C tagadab niko 2 plus 3 lambda minus lambda plus 4 lambda plus 2 plus 2 lambda is equal to 5. 2 plus 3 lambda minus na multiply to siko plus 1 minus 4 lambda plus 2 plus 2 lambda is equal to 5. 3 lambda ga 2 lambda ga di 5 lambda ko minus 4 lambda 2 plus 1 3 duga 2 ga di 5 tare ko 5 cancel to re and 5 lambda minus 4 lambda is equal to lambda, and by solving this equation we get value of lambda is equal to kya ga manare 0 phange ko. So putting the value of the lambda equals to 0 in the coordinates of B, 2 plus 3 lambda minus 1 plus 4 lambda and 2 plus lambda, then we get kay phangani B is equal to 2 minus 1 2 si B c0 chatlani c0 chatlani c0 chatladi 2 minus 1 2 si coordinate se phange ko. Housing na ngasagi diagram sida nangi B gi coordinate phange. Housing B gi coordinate se kya ga managre coordinates of B is equal to 2 minus 1 and plus 2 sitare ko. Housing makhata na kay puthokani. Now we are going to find the distance between point A and the point B. Simulog si ko. Point A ga point B ga gi difference log. Hence, distance between AB is given by root over x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Sigi formula se mug use tawrasi ko. Nangi B sing sina x2 y2 z2 nena khalo, A gi sina x1 y1 z1 nena khalasi ko. 2 minus 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 plus 2 plus 1 whole square and a minus 1 minus 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 plus tare ko. Minus 1 plus 5 whole square plus and 2 minus 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 plus 2 plus 10 2 plus 10 whole square sitare 2 plus 1 whole square 9 phange ko and 4 square 16 and 12 square is equal to 144. There sum put hodi kya ga manare root over 169. The 169 is the square root of 13 square and hence the distance between the point A and the point of intersection of the line and the plane is equal to 13 units. Sigi mawong da koina anka hotare ko. Next question is question number 19. Find the vector equation of a line passing through the point 1, 2, 3 and parallel to the planes. Nangon the plane ani ama supire ko. Sina question number 19. Mathangi question se question number 19. Koina puthok tu sigi line sigi equation neba. Now we're going to derive the equation of this line L passing through point A with coordinate 1, 2, 3 and parallel to the two planes. Plane ani sega parallel taba ko sina plane 1 ne sina plane 2 ne and n1 is a vector normal to the plane 1 and n2 is a vector normal to the plane 2. And let us suppose that m vector be a vector parallel to the line L or acting along the line L. Then from this figure we see that this m vector is perpendicular. This m vector is perpendicular to both n1 vector and n2 perpendicular tadra nang figure sida. Judisigi m vector se kaina pirakani n1 vector cross n2 si concept sida ko yengsi ko. Let A is equal to 1, 2, 3 be a point on the line which is parallel to the two planes. Equation of the planes are r vector dot I cap minus j cap plus 2 times of k cap is equal to 5 and r vector dot 3 I cap plus j cap plus k cap is equal to 6 in a line 1 is in a kaino line 2 ni plane 1 is in a plane 2 ni. Equation of the planes ito ko mathang da kai ini n1 n2 is equal n1 haidi koina plane 1 the normal oiba n2 sina plane 2 the normal oiba si n1 tare sina kai tare n2 tare ko sigi mong de ito let m vector be a vector parallel to the line nang kanada parallel oiba line to the parallel oiba vector samani ko. Let m vector be a vector parallel to the line and so this m vector is perpendicular to n vector and this m vector is perpendicular to n2 vector tare ko. And this m vector is given by the cross product of n1 and n2. Vector amana atoba vector anida perpendicular oiragadi m vector se cross product of two vectors tai ko n1 ga kana ga cross product law tare n2 ga cross product law rani dudi I cap j cap k cap then write the components of n1 1 minus 1 2 si thoni ko then write the components of n2 3 1 1 si rani ba si re ko expand tawre kana ko na vector samphange ko expanding along first row I cap ire first row ka first column cancel already minus 1 1 minus 1 2 into 1 minus 2 form lagi minus samga minus j cap 1 into 1 1 tare ko 2 into 3 6 plus k cap 1 into 1 is equal to 1 duga minus 1 ga 3 ga di minus 3 minus minus plus tare ko minus 3 I cap plus minus 5 minus minus plus taradra 5 j cap plus 4 k cap sinangi vector amani ko kanada ek tawraga leiba nangi line sida parallel oina ek tawba and therefore the equation of the line passing through point A coordinates kyano 1 2 3 and parallel to m vector. Equation of the line passing through point A and parallel to m vector is kaitane r vector equals to a vector plus lambda times of m vector sinapire ko a vector means position vector of any point on the line haiba is equal to 1 I cap plus 2 j cap plus 3 times of k plus lambda le ko. Then write the components of m. This m vector is given by minus 3 I cap plus 5 j cap plus 4 times of k. So my tawraga nangi equation of the line set derive to biyani koina rough diagram ama yekani ko adugi matungina anka holani. Next question number 21. Last question ni ko. Prove that if a plane has the intercepts A, B, and C and is at a distance of p units from the origin, then show that 1 by a square plus 1 by b square plus 1 by c square is equal to 1 by p square. Distance have a piramagadi equation of the plane se normal form the irakadavani ko. Prove that a plane has the intercepts A, B, C and is at a distance of p units from the origin, then haraga among the left hand side ki expression se right hand side ka mane na prove tawgadaba ko. First, we have to write the equation of the plane in intercept form. Equation of the plane making intercepts ABC is given by x by a plus y by b plus z by c is equal to 1. Nangi intercept form ni ko. ABC se x da y da z da set by intercept nga to ni. Equation 1. Let n vector be a vector normal to the plane 1. Plane 1 the normal over vector neba. Didi si n vector se kay napirakani. Coefficient of x, y, z ni. 1 by a I k plus 1 by b j k plus 1 by c k cap si tare ko. Equation of a plane making intercept ABC gi nangi form hana ithoni aduga normal laurani. Normal laure ko. Si laurabu matungda nangi equation of the lines. Equation of the plane se normal form the e bayanaba. Magnitude of n putoxiko. Magnitude of n is equal to root over 1 by a square plus 1 by b square plus 1 by c square. 1 by a si x component ni sida ko. Nangi x component, y component, and kay laigre z component laigre. 1 by a x component, 1 by b y component, 1 by c z component tare ko. Then 1 by a square plus 1 by b square plus 1 by c square. Then dividing both sides of the equation by kaina divide tore magnitude of n we get x by a plus y by b plus z by c divided by root over 1 by a square plus 1 by b square plus 1 by c. Nang right so 1 divided by 1 by a square plus 1 by b square plus 1 by c square tare ko. Sigi x, y, z se r vector ne dot 1 by a, 1 by b, 1 by c se n vector da thame ko. Divided by the magnitude of kaina divide to gadaba the magnitude of n na divide to which is equal to 1 by root over 1 by a square plus 1 by b square plus 1 by c square. Equation of the plane in normal form se r vector dot n vector is equal to d neba. D is the distance of the plane from the kai haigi origin haigi dana. Adugi n cap haibasina nangi plane do the normal over unit vector ramani. Sigi form the tarak na bagi damakta akoina both sides of the equation the magnitude of n na divide to neba. So r vector dot n cap n vector the magnitude na divide over the n cap tare ko, which is equal to 1 divided by root over 1 by a square plus 1 by b square plus 1 by c square tare ko. Nangi right hand side se kay represent away the expression in right hand side represents the distance of the d from the origin, and so we have this d is equal to 1 divided by root over 1 by a square plus 1 by b square plus 1 by c square tare ko. But it is given that the distance of the plane from the origin is p units pire, and so d is to be replaced by p is equal to 1 by root over 1 by a square plus 1 by b square plus 1 by c square tare ko. Then taking squaring on both sides, we have c eliminate ko. In order to eliminate this square root, we have to square on both sides of the equation, and we get b square is equal to 1 divided by 1 by a square plus 1 by b square plus 1 by c square. And taking cross multiplication lorena traga reciprocal lowers ko. Taking reciprocal on both sides of the equation, we have 1 by a square plus 1 by b square plus 1 by c square. It will be equal to 1 divided by p square. So main tauraga nangi problem se solve to ko. For today, let's end here.